Another approach that everyone eventually finds themselves needing to use to optimize their code is parallelization. Now, it's important to note that when you parallelize code, you're not actually reducing the amount of work that gets done. You're just breaking it into chunks that are being done by multiple workers, either multiple threads, multiple processes, multiple workers at the same time before you're able to finish processing that and get it back to your customer. So you're reducing latency, meaning the wait time. You're not actually reducing the total workload. And it is definitely important to look, within your code and see if you can reduce that latter issue. But as far as a way to take advantage of the multi-processing capability of modern processors and GPUs, CPUs and GPUs, parallelization is key. So most modern languages, they have a notion of promises, and they have an architecture, whether it's promises, whether it's coroutines in some languages, straight up multi-threading. It's worth noting, so this is one of the drawbacks of Python, is that Python is relatively weak. So I'm going to put Python here and I'm going to cross it out. Unfortunately, it's relatively weak, particularly on the multi-threading. There are approaches that work in Python. Increasingly, there are libraries. There are approaches that you can take to straightforward parallelization. But let me introduce another approach that is commonly used, and it's easy to use, that your developers might, that they can leverage, whether it's from Python, whether it's from, full stack JavaScript, doesn't matter, Java, .NET, anything else. And that is using queuing, or essentially asynchronous messaging we'll call it, for parallel processing. So what this really means is using a system like an SQS, that would be Amazon, but like an SQS or a Kafka, I think I spelled this right, or RabbitMQ. And so rather than trying to write multiprocessing code, which a lot of times you see developers, let's say in the promise example, they end up using async awaits, in JavaScript as an example, which kind of defeats the purpose of the multiprocessing. They are basically just waiting on the call to finish. And that's appropriate in some cases, but it does defeat the parallelization. When using queuing, basically what's happening is that you are taking, a single thread of work that might, I don't know if it's 1 million jobs you got to do, it's 1 million in a row, and you're publishing it onto the queue. And so let's say here's the queue. So it goes on there, and then the workers are grabbing these guys off. And so if there's n workers, then n different jobs can get done at the same time. So that's the beauty of taking a queuing approach, and it's very straightforward to implement. In particular, if you use AWS and SQS and say Lambda, say serverless functions, you can set them up to just grab stuff straight off the queue, and those can scale in parallel as broadly as you want. So you can really have tremendous performance from that approach. But yeah, this is sort of I don't want to say neglected, but one opportunity that your developers might have to really improve performance by bringing in a queuing or messaging system to help manage workloads and run them in parallel.